In this presentation, we will discuss the common characteristics of fractals in nature. First, we'll start with the basics. What is a fractal? A fractal is a geometric shape that possesses some form of self-similarity. What is self-similarity? An object possesses self-similarity when it looks like parts of itself on a variety of scales or levels. Objects in nature often possess approximate self-similarity, finite self-similarity, and local self-similarity. Approximate self-similarity occurs when the progressive generations or levels of an object are similar but not identical. Finite self-similarity occurs when an object's generations do not possess self-similarity at a never-ending amount of generations or levels. Local self-similarity occurs when the trait of self-similarity is only observed in specific areas of the object, as opposed to any and all areas of the object. The following slides will give examples of fractals in nature which possess various forms of self-similarity.
Fractals in trees. My eye has always been drawn to a mighty oak tree that stands in the middle of a field. I find this to be a repeating pattern in itself across rural America. When allowed to grow without competition, the oak tree creates a beautiful canopy that I now realize I was drawn to for its self-similarity. Humans consistently attempt to mimic nature's beauty in our own way. We have managed to recreate the tree branch effect with electricity sent through plexiglass as well as a block of wood. A wonderful representation of an infinite repeating pattern in trees is the banyan tree. I was able to see one in Lahaina, Hawaii. The banyan tree starts out by growing out of a host tree that it eventually consumes. It grows out branches and then sends down roots to the ground. If left unchecked, these trees will grow almost forever, and the one in Lahaina takes up almost an acre of space and is well over 100 years old. Not only do trees in themselves attract the eye with their fractal qualities, but they create and grow their very own fractals. Many evergreens produce pine cones, nuts, berries, and those helicopter things you played with as a kid, and much more that have repeating patterns as well. As noted in the previous slide, humans consistently attempt to mimic nature's beauty in our own way. The pictures in this slide show an example of how we have managed to recreate the tree branch effect with electricity sent through plexiglass on the left, as well as a block of wood on the right. This slide shows a photo of the banyan tree, which is a wonderful representation of an infinite repeating pattern in trees. Fractals in food. There are many fractals visible in our foods, but we don't always notice them. Some of these foods we must cut into before we notice the hidden patterns, like onions, celery, and kiwis. Others show their mathematical tendencies on the surface, such as cabbage, sunflowers, and artichokes. The petals or leaves of an artichoke bud create a beautiful repeating pattern around the stem and are actually of the thistle family. We prefer to consume the meaty inner leaves and hearts of the artichoke before it blooms, but if allowed, it will grow into a large thistle flower that has fractals in its own ways as well. Whether in bloom, cut in half crosswise, cut down the center, or as a bud, the artichoke offers an array of fractal images. An artichoke exhibits a finite self-similarity because it occurs at multiple levels, but eventually stops, similar to the Romanesco we read about in Chapter 12 of Modern Mathematics. As it blooms, though, I found it has a certain Mandelbrot set quality. The bud opens up to create a wonderful purple thistle that if it was filmed and played in fast forward, it would appear to be zooming in on itself, creating a mixture of infinite and approximate self-similarity, similar but never identical, which seems the trend for fractals in nature. The unique environment of our oceans makes for beautiful and unusual fractal shapes. There are literally millions of different types of plants and animals in our oceans. Fractal shapes can be observed in the tiniest diatoms, which can only be observed through microscopes. These tiny creatures exhibit different types of self-similarity. Corals provide an unlimited source for finding complex fractal shapes, from the flower-like polyps of this alveopora coral to the labyrinth-like brain coral. These animals are both made up of fractals and create colonies of fractals. The nautilus is a perfect example of finite self-similarity. As this cousin to the octopus grows, it creates larger and larger chambers. The result, sliced in half, shows an example of the mathematical equation for a feedback loop. Fractals in insects. Flies, with their compound eyes, are a fantastic example of fractals in nature. Each eye is actually made up of hundreds of smaller eyes, which work to create a slightly strange, honeycombed view of the world. Spider webs are another good example of fractals in nature. The kinky geometry in this web creates an interesting pattern that is best viewed in the morning when dew hangs on the strands like tiny strings of beads. Butterflies have two types of fractals on their wings. The first is the design that we are familiar with on the wings. The second is a little harder to spot without a microscope. Each wing is made up of thousands of colored feathers, which help the insect fly. If you have ever caught a butterfly and noticed your fingers dusted with colored powder when you let it go, you have touched the feathers of a butterfly. Whether approximate, local, or finite, fractals are everywhere in nature. The next time you are outdoors, on a hike, out camping, or even in your own backyard, take a look around and see if you can spot the self-similarity of fractals in surrounding trees, flowers, plants, and insects. If you are interested in learning more about fractals in nature, we encourage you to check out the information presented by the Fractal Foundation and the link provided.